Hello, it's been quite some time. I mean, in terms of between the last time I uploaded a video for one of these series specifically today. So, welcome back. I will continue and moving forward, hopefully, 3 more videos and that will be it. I will see. So, just to very quick recap, this is a prioritization, a landscape prioritization for a group of amphibians, right, in a certain location in Mexico City. So basically, we are aiming towards a map like this, but it's going to have more details, more stuff, right? So far, in order to accomplish this, we have done a couple of things. So we have set up a group of species. In this case, it's 10 species and 10 amphibians. We have bring a set of variables that consisted in climatic or environmental, blah, blah, blah. But it has to do with climatic information for past, current, and a future scenario, worst future case scenario. We already have done the modeling of the species, suitability areas or distribution areas, right? Depending on who you talk, it will give a different concept. And now we are moving already into the prioritization. I have already talked a little bit of what is this about and some of the components that are needed. So I'm gonna keep going into this recap, right? So Zonation is a software, right? That it consists in an elimination of a set of species in this case, right? So it's like basically it's deleting the information that we have, and in that way is going to prioritize where is more likely that we have the group of species depending on a given rule. In this case is the highest value of the distribution model, meaning where I have the most likelihood of having the species, that is the most important area that I need to be taking care of. That's kind of like the setup. Yeah. Now for Zonation, we need a couple things. This is basically the conceptual model that I use. In one hand, I needed to create a hierarchy among the species, saying like, okay, according to the conservation status, national and international, and also the status in terms of trade, international trade. So these are the most important species that we can have. Again, there's one of the videos. I will try to specify maybe in a notation or something, so this can I can just move on more quickly, right? So I create that hierarchy, and also I bring information such as dispersal capabilities. Now the dispersal capabilities I mentioned is a very controversial information because we need to have the specific data for each one of our elements, right, of individuals. So in this case, I use a publication where they managed to do some kind of averaging an estimation or something like that, right? Also, we need to have the models, the suitability, the distribution models, uncertainty, meaning where my prediction went a little bit out of the boundaries of what I wanted. And also we need to have urban areas as some kind of a mask, meaning I will omit, even though in terms of the environmental information and the distribution models, I might have certain conditions, the fact that it's an urban area needs to be completely eliminated. Now, I did this prioritization in 2 kind of sets. One is by each one of the terms of times, periods, by themselves, meaning past, present, and this future scenario. I am not originally I did this one, but I'm not doing it right now for the sake of this exercise. So we are working only with RCP 8.5. The other way is using distribution interactions. The idea of this one is it gives you the calculation like a transition between past, current, and future. So it's kind of very kind of cool conceptual thing to do, because it tells you like how my area might be more consistent through time, right? Because in terms of planning, if we're going to be working with planning, we need to consider how things move, how the conditions will move on, right? So yeah, so that's basically the conceptual thing, and this is how the core area, which is the rule that we will be using, because there are another ones, right? This is how the core area works. So imagine that I have, in this first one, right? So imagine that I have one species, right? And I have a value of 1.8, 9, 2, 2.1. Obviously, the higher means better conditions for that species. So what zonation does is identifies where do I have the lowest value, and it will eliminate that, and that's how it's going to be. Now, this is also important in the way, and the reason why I represented this in percentages is because I am working in terms of if I want to prioritize 50% of the territory or 17% of the territory, which here is where we need to look at the international goals, where they talk about like, oh, we need to preserve the 30% of the landscape, right? Or at least have it under some kind of protection, and so on and so on. So that's the whole idea. Now, core area zonation works. Imagine that I have two species. So what it's going to do is going to take the highest value of the species. So we will have exclusively, independently of the species, we will have the highest value of the best conditions, independently of the species. It will identify the best conditions, conditions of the models, and that's the parameter that we'll start using to eliminate. So that's basically what it is. So now, what I want to show here is a couple things. It's how do we set up zonation, like actually the software, right? The software looks something like this. I might try to do a run right now. It's something very quick, sorry. So I want to go through, this is the software. Actually, I do have the project loaded right now, so maybe I can do one of those runs. So how do I manage to actually work? So we need to have a couple of files, right? Basically, the master file is a file that it has the extension BAT file, right? Now in this BAT file, if you see these images here, I basically just cut the file, right? Cut in the image, right? So it is telling us all the components that we need. That's basically it, right? So I want to go through those. Just to get out of the way, the very first line, which is like policy, blah, 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 is like execute the software, right? Now, what's up with the following file? So the set KS and KSZ, this is the setup, right? The one that actually tells me like all the setups, that how do I want the rule, the rule of elimination, if I'm going to use mask, and so on and so on. Now, sure, some files that are very important is the mask file. This is basically how it looks, the one that I use, which is all the localities where I do have urban or very well constructed rural areas, right? Now, the species file, it looks something like this. I will go into detail in a second for this one, right? But here basically is like where do I have the list of the files? And oh no, I am sorry. I'm so sorry. So the uncertainty list file. So the uncertainty I mentioned a moment ago, like that we need to have that information, right? The uncertainty, it looks something like this. It's telling me in this case is the red areas is where my model got outside of my evaluation. Again, you will need to check the other videos to understand what do I mean by the evaluation. But basically is like, I did each one of the models that I produced had a statistic value that tells me this product is significant or is relevant, right? But so at the same time, I did produce like where do I have certain models? Where is more likely to have uncertainty, or where is more likely to have not trustful results in my model? Now let me just go ahead. Hopefully I will go through the file actually. So this is how it looks. This is how it actually looks. And so kind of, I'm gonna try to speed a little bit like line by line, right? So this is, on my right side, I have the manual, right? How is the instructions, right? So the removal rule, this is what I meant. This is the type of rules that I have. They have their benefits and they're not so cool things. So it's going to depend on the kind of objective that you want. In my case, I wanted to represent the best conditions, the best suitability conditions, according to that. But additive benefit function, for example, the rule that it uses is that it actually makes the sum of all the models. So it's a more richness focus. Yeah, so it's like, where do I have, in terms of group, the whole group of species, where do I have the most, the highest values, or where is more likely to have most of the species, right? So for this exercise, I use the basic core area zonation. Maybe, I mean, I could try to do how does it look with a benefit, but no, or whatever. Now the wrap factor is, because we are working with an image, and an image has grids, has cells or pixels, let's put it that way. So this is the rule of how many cells we are going to be removing. This is a setup that I didn't want to move on, so it's going to be eliminating 100 cells by 100 cells, right? I think the overall square that I'm working with, it was around 200 or 400 or 200,000 something cells. Then this prioritize if we want to remove on the edges or from the inside, right? Okay, yeah, so here's what happens with from here now, from the line 4 to the line 10, has to do with with certain rules, like for very specific purposes, right? The first one is like, if I want to prioritize removing from the edges or removing from the inside, but at the same time I can provide the edges points, right? So I can prioritize like where do I want to be removing that. So basically this is what it is, right? Which kind of edges I want to prioritize. So moving to this one is species of interest. So even though if I am already working with a hierarchy setup, I can have a very specific species that I am interested to take in part of. So I'm not going to go through all of these lines. I'm going to try just to focus on the ones that I modify, right? But these last 3 lines again is to prioritize, to make focus on a given species of interest or a very particular setup that I want to have or I want to represent, especially. Now the line 12, the cost file. This is a very cool and interesting one that I will love to mess around in the future. because this is the cost file, which basically tells me the areas where I might have less ideal conditions for the species. Basically, that's what it is. I have the other series that is about the economic agricultural production. That's a very good case to very good information to bring in this part, because where I do have very intense agricultural activity, it might not be, it would be the most costly to the species, right? Yeah, how am I? So I need to speed up. I think I need to. I'm going to have that. So here, as a cost file, I'm using the urban, the locality, the urban areas, right? And so, and I wanted to use it as a mask, right? Not as a gradient. It's like cut up the whole thing. And the boundary penalty, I don't want to be jumping around this. Where are you? Okay, so I think this one goes more into the connectivity. I'm gonna be because I'm eating way too much time here. So I didn't mess with any of this file with this setup, but this is basically like, if we want to consider more, I think yes, I think that's it. I'm not even going to bother reading right now, because focus on the connectivity among certain areas, right? Then, yeah, so all of this has to do with connectivity, right? Because this is also important, like where do I have areas that can present a flow for the species? The Z, let me just go straight up to the Z. Extinction risk value. Gonna be entirely honest here, I think this score is also like, yeah, the default over here. So it's also stayed as default. So I didn't mess up anything from this part of the setup. Zero data. And okay, so the last thing. Okay, so in the last part of this setup, right, here's where I am bringing the hierarchy among the species, the weight. The weight of the species, it's basically what it's going to do is, if I should prioritize roach, right, I'd be using that word way too much. If I should focus on not eliminating that species, yeah, because this is the most important. So basically, this is what it is on this setup, right? This is the one used for a single time period. I think I still have time to speed for this setup. This is the setup for the interaction among the time lapses, right? So once again, we have basically the same setups over here, the same things, penalty, blah, 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 right? But here's the thing, interaction. So this is the part about the connectivity or interaction among my distribution information, right? So how do I want them to interact, and who do I want to interact with, right? So this is a bunch of lists. Now, this is how those files look like. Yeah. This is the specific interaction. Now, what does these numbers mean to? I have a very beautiful and artistic image. How am I with time? Oh my gosh. Yeah. I finished this, and that will be it for this video. So imagine, so I have 10 species, right? I have 10 species, 1, 2, 3, 4, 5, 10. Now, this is the philosophy behind the interaction. So I have to run the prioritization as a single time period, and also as an interactive time period. That means that I need to have the past listed twice. because one is going to be run as a single thing and the other one is going to be run as against someone else. And the logical step is from past to current information. Once again, I have the present here. I need to have it on two sets because it's going to be run by itself and interacting with the future. So I basically have one final result where I have the time period passing from past to current to the future. And obviously, the future information should not be modeled by itself because it's not going to be interactive. But this is why I have 9 and then 10 interacting with 30, because this is basically this jump. So for example, I have 1 to 10, 11 to 20, 21, blah, blah. You see, it's just repeating the species. So the first one, 1 is going to interact with 21. 1 with 21, which is present, right? And the number 10, which is the first species, no, sorry, and the number 21, which is the first species from the current time period, is going to interact with the first species from the future period. That's why we have 21 interacting. Oh no, you see, I need to correct this one. So here, what I need to do, 1 second, I'm gonna pause it and I'll be back. And we're back. So this is the correction that I needed to do only, if I'm correct, because it's the current species interacting with the future species, and that's it. I'm just going to save this, and that's it. And here's the more detailed version of that file. I'm not going to even bother because at my time, we've been here way too much time. Which long? I don't know what am I even saying. Even my light just went off. Okay. So I have the setup for the interactive file. I will just go ahead and run the one for current information. I will not run the other one. Okay? Or should I? Well, I'm going to leave it over here. I'm going to make a cut and I will continue with the other information, with the other files, and then with the run. Okay, so apologies, it took me way much time than I was thinking. So, but until the next one, thank you.